Real-life application in both derivatives and integral. Here, we've got an AP Calculus BC free response question from 2015. From the text, we can learn that function R is the rate at which rainwater flows into a pipe, and function D is the rate of rainwater flows out of the drain pipe, and their time intervals are both from 0 to 8, and also there is an initial condition saying that there are 30 cubic feet of water in the pipe at time t equals to 0. Let's finish the first question. How many cubic feet of rainwater flow into the pipe during the 8-hour time interval, t from 0 to 8? The question asks about rainwater flowing into the pipe, so we need to go back to the context and find related information, which is function r. Now, we need to work on function r, which is 20 sine t squared over 35, to get the correct amount of cubic feet of rainwater flowing into the pipe. Now, we need to make a clarification that the question is asking about how many cubic feet of rainwater flowing to the pipe, instead of how much is the amount of water in the pipe during the time interval t from 0 to 8. So, flowing into the pipe does not equal to how much water in the pipe. So we temporarily ignore the initial condition that there are 30 cubic feet of water in the pipe at time t equals to 0. We have already learned the definition of integral and how to use an integral. So at this point, we have already known the rate at which rainwater flows into a drain pipe. So we use an integral to calculate the amount of rainwater flowing to the pipe during the interval 0 to 8. So we start an integral from 0 to 8 rt dt, and we just write out the function to get some points during the AP test. And then, because this is a graphing calculator required problem, so it is very easy for us to integrate it. We just type the function into the calculator. You do y equals first, and then you just type in the function. After that, you hit graph, and then you hit second calc to option number 7, which is integral. And then the calculator will ask you which is the left and right bound. You just say left bound is 0, right bound is 8, because the time interval is from 0 to 8. And then the calculator will just give you an exact number of the integral, which is 76.570. And don't forget a unit here, cubic feet. And that's the first question. Then we move on to question B. Is the amount of water in the pipe increasing or decreasing at time t equals to 3 hours? Give a reason for the answer. Because we have already known how fast the water is going in and out of the pipe, so we just combine these two functions together, which is r3 minus d3, and then we can get how fast is the water flowing in or out of the drain pipe. So we just plug in the number, just type in the number in the calculator, put two functions together, and use r subtracted by d, and we just plug 3 into the positions of t's, and then we can get the value, which is negative 0.3136, which is negative. What it also means is that at t equals to 3, the water going out of the pipe is faster than water going into the pipe. And then we can draw our conclusion that at the time t equals to 3 hours, the amount of water in the pipe is decreasing. And that's the end of our problem number B. And about problem C, at what time t from the interval 0 to 8 is the amount of water in the pipe at the minimum? First, we need to find at what time the rate of change of the water in the pipe equals to 0, because when the rate of change equals to 0, it means it's either minimum or maximum, because it either stop decreasing or stop increasing. So in this case, we're finding out at what time the rate of change of water stops decreasing so that it reaches minimum. So now we write RT minus DT equals to 0 to represent that the rate of change of water equals to 0. Now we can take out our graphing calculator and type two functions in one equation using function rt subtracted by function dt. And then we hit graph, and then we do second calc and find choice number 2, which is 0, and you hit it and set the left bound to 0 and right bound to 8 because the time interval is from 0 to 8, and hit gas. Now the calculator just calculate the exact t value, which is about 3.271658, and in AP test we can just round it to the nearest 3 digits. So it's about t equals to 3.271 or 3.272, and we finish our problem C. Let's move on to problem D. The pipe can hold 50 cubic feet of water before overflowing. For t greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Write but do not solve an equation involving one or more integrals that gives the time w when the pipe will begin to overflow. In this case, we are talking about how much water is there in the pipe. So we need to consider the initial condition, which is there are 30 cubic feet of water in the pipe at time t equals to 0. Now we start our equation with 30, and we add on the value of the amount of water going inside and outside of the pipe during the process. And the time interval is from 0 to w, so we just say the lower bound is 0 and upper bound is w, and then we write in the rate of change, which is rt minus dt, and then integral the rate of the change so that we can get the exact amount. And the initial condition is 30 plus the amount of water in the integral equals to 50 cubic feet of water, and that's our answer to problem D. Now let's take a look at another AP Calculus question from 2016, question number 5. The inside of a funnel of height 10 inches has circular cross sections as shown in the figure above. At height h, the radius of the funnel is given by function r, where h belongs to 0 to 10. The units of r and h are inches. Find the average value of the radius of the funnel. What is an average value? Average value is the values adding up together divided by the number of the values. So in this case, we do an integral, integrating the sum of the radiuses and divided by 10, which is the number of the interval. This is a non-calculator question, so we need to do the integrals by ourselves. Now, we first write out the equation RH to 1 over 20 times 3 plus h squared, and then we take out all the non-h numbers, which is 1 over 10 and 1 over 20, and we put them out, and then we do 1 over 200 times integral 0 to 10 3 plus h squared dh, and then we integrate the numbers in the integral, which is we get 1 over 200 times 3h plus h to the thirds over 3, and then we plug in the numbers 10 and 0. We get 1 over 200 times 30 plus 1000 over 3 minus 0, and then we simplify it. We get 109 over 60 inches. And that's the answer to our problem A. Problem B. Find the volume of the funnel. It is a little bit complicated to think, but as I draw some slices on the graph in the text, I mean that every slice that I draw is a single circle, a single two-dimension circle, and if we stack them up, they made up a volume. So in the volume, what I mean here is delta H, which represents the height of the volume, times the pi r square, which is the areas of the circle. Because what I mean that is if we stack them up, they make up a volume. But in AP tests, these are not the correct thing that we should write. What we need here is an integral from 0 to 10 because it is the height interval. And inside the integral, we should write a formula of the areas, which is pi r function square. And then we pull out pi out of the integral because pi is a constant which doesn't join the process of integration. And then what we need to do is to write the r function into explicit numbers, just like how it is provided from the text above. Our next step is to pull out another constant, which is 1 over 20 squared. Then we get pi over 400 outside of the integral. And then what we need to do is to expand the numbers under the parenthesis to make the integral simple. Our next step is to integrate the formula in the integral, and then we can get pi over 400 times 9h plus 2h cubed plus h to the fifth over 5, and then we can plug in the numbers of 10 and 0 when we use the numbers plugged by 10 subtracted by the numbers plugged by 0, and then we can get our final answer of the volume, which is 2209 pi over 40 cubic inches. Problem C. The funnel contains liquid that is draining from the bottom. At the instant when the height of liquid is h equals to 3 inches, the radius of the surface of the liquid is decreasing at the rate of 1/5 inch per second. At this instant, what is the rate of change of the height of the liquid with respect to time? So let's make this clear. The question is asking what is dh over dt, which is the rate of change of the height at h equals to 3, while the rate of change of the radius dr over dt is negative 1/5, because the question says the liquid is decreasing. So we just write dr over dt as a negative number. First, let's consider what makes up dr over dt. It is dr over dh times dh over dt, where both dh can cancel each other out, and we keep writing our equations. So for the left, dr over dt, it is provided it is negative 1/5, and at the right, dr over dh. So in the text, we are given the function r, and we can get dr over dh by just getting the derivative of function r, which is 1/20 times 2h, where h is 3, because the problem C just said at h equals to 3, and then we can get dr over dh is 3 over 10, and for dh over dt we can just easily get calculated out, because the other two has been already calculated. So dh over dt is negative 1/5 times 10 over 3, and finally we can get negative 2/3 inch per second, and that's our problem C. Thank you for watching, and for further questions don't hesitate to email bcclassofta@gmail.com. And last of all, before you leave, please hit the subscribe button and leave your like. Thank you.